Okay, let's look at the adaptive locomotion, which is the long jump run-up. And how does the athlete achieve the accurate placement of the foot? The plate, the size, the width is 20 centimeters. And in order to accurately place the foot and maximize the speed of run-up, well, we can say maybe each footstep is pre-programmed across the whole run-up. Or the second assumption would be, well, maybe there will be the stage to build up the speed, and last few steps will be used to adjust the accuracy of the run-up. And the scientists found out the last few steps actually varies across run-ups, and this might indicate in those adjustments the athletes might use the time to contact with visual information in those stages. So Lee, Leishman and Thompson in 1983 videotaped the 3 female athlete long jumpers, and they could identify what was similar to the second assumption. They could identify accelerated phase, which had the regular footstep length, and they were building up the speed. And the second phase, which is known as zeroing in phase. So that reduces the error of the footsteps. And that zeroing in phase was composed of 6 final steps, and at those steps the length adjustment occurred. And about 40% of errors were adjusted on the last slide. How did they know? Let's have a look at their results first. So the top graph shows the stride length and the stride number before takeoff. So this was actual takeoff, and this one 2 steps before, 4 steps before. When they measure the stride length, which is between foot to another foot, the lengths in that stage were kept constant, so almost constant. And the last 6 stride, the step lengths varied. And look at this one. It's the standard error of footfall position. What is that? What is mean by that is when there's a plate and there's the last step, take off, and the second last, third last, fourth last, fifth last, and so on. What they measured was the footfall position from the target. So let's say this is the target and this is the footfall position. So they actually measure the distance. So it's the second last one, and the distance for the third last one is this one, and the distance for the fourth last one is this one, right? And so on. And what they measured is the standard error, so the variability of that distance across the trial. So they averaged the step length, footfall position, which is this distance, across the trial, and they found the standard error, which is similar to standard deviation. So looking at the variability of that distance. And as you can see, as they come closer to the target, their variability increases. but at certain points their variability begin to decrease. So it's about 1, 2, 3, 4, 5, 6. Starting at the 6th steps, the variability began to decrease, and at the 0 step there's no error because it's always near the target. So the variability of the distance of that last foot is always near the 0. So by looking at this, they suggested that at from the 6th step, because the variability becomes to decrease, the adjustment begins from the 6th step. That was their inference from this graph. When they calculated back the percentage of adjustment made, this is the graph. This is the last stride before the takeoff, second last, third last, and fourth last. And this is the average percentage of adjustment made. And as you can see, it's for the nearing the final stride, the adjustment increases. So it's like funnel, like control strategy. So it's like a funnel, which means as they near the target, the more adjustment is made, and this is possible by tail information.